Space looks calm, a velvet sea scattered with stars, a silent, eternal canvas. But hidden inside that beauty are dangers, some proven, some purely theoretical, that could end life as we know it. The question is simple, yet terrifying. What happens when the universe stops being kind? Today we're going step by step through levels of cosmic threats, from the smallest sparks to the most unimaginable endings. And by the end, you'll see why the fact we're still here is nothing short of a miracle. Level 0. Before we dive into threats, let's set the baseline. Earth, our home, looks stable, but really, it's a fragile balance. A glass bubble floating in a cosmic ocean. Picture this: 86 billion neurons fire inside your brain, making thought possible. Now zoom out. Earth itself is like a brain cell inside the galaxy, firing its own delicate spark of life. We orbit the sun at just the right distance. Too close, and oceans boil. Too far, and Earth freezes into a snowball. The thin film of the atmosphere shields us from radiation, traps warmth, and keeps water liquid. Our magnetic field deflects deadly solar particles. Everything that makes life possible is held together by razor-thin margins. And space? Space is indifferent. It throws rocks, flares, bursts of radiation. Sometimes those threats miss us. Sometimes they don't. If Earth were a spaceship, we are passengers who never asked for tickets, riding inside a thin hull we barely understand. The first cracks appear when the cosmos reminds us how fragile that hull really is. Level 1. The sun sneezes. Earth trembles. The sun is our lifeline, providing warmth, energy, and light. But it is not a gentle star. Inside, nuclear fusion rages. Magnetic fields twist and snap like rubber bands. Sometimes that tension erupts outward. These eruptions come in two forms: solar flares, sudden flashes of radiation, blasting X-rays, and UV light. Coronal mass ejections, CMEs, enormous bubbles of charged particles thrown into space, sometimes billions of tons at once. When a CME hits Earth, it can rattle our magnetosphere, trigger auroras that dance as far south as Texas, and wreak havoc. Think of it this way: spilling coffee on your laptop fries its circuits. A CME is like spilling plasma on Earth's entire electrical system. The Carrington event of 1859 was one of the strongest solar storms ever recorded. Telegraph lines caught fire. Operators received shocks. Auroras lit up the sky so brightly, people thought it was dawn. If that storm struck today, satellites would fail, GPS would vanish, and power grids could collapse for months. NASA estimates the chance of a Carrington-level event hitting Earth in the next decade at 10 to 12%. Not guaranteed, but not zero. That means the star that gives us life could also knock us back to the 1800s. No internet, no navigation, no power. And that's just level 1. Level 2. Space throws rocks constantly. Most are small, burning up as shooting stars. But every once in a while, one survives the plunge. 65 million years ago, one such rock, roughly 10 kilometers wide, slammed into Earth. The result? Tsunamis, wildfires, decades of darkness. Dinosaurs, once rulers of the planet, were wiped out almost overnight. That was level 2 in action. Today, we call it the cosmic lottery, because Earth is always buying tickets whether we like it or not. NASA's catalog of near-Earth objects, NEOs, tracks more than 30,000 space rocks larger than 140 meters. A strike from one of those wouldn't necessarily end humanity, but it could flatten a region, collapse economies, and change climate for years. To put it in perspective, in 2013, a meteor 20 meters wide exploded over Chelyabinsk, Russia. It shattered windows across 6 cities and injured over 1,000 people without ever hitting the ground. Scale that up to 140 meters, and you're looking at a city-level disaster. Scale it up to 1 kilometer, and it's a global crisis, blocking sunlight, collapsing crops, and destabilizing life everywhere. Imagine you're playing baseball, you're the catcher, but instead of pitches, the asteroid belt is hurling rocks. Most fly past, but all it takes is one wrong throw to change the game forever. The good news, we're watching the skies. NASA's DART mission in 2022 proved we can nudge an asteroid's path by smashing a spacecraft into it. A cosmic game of billiards, but with planetary survival at stake. Still, Level 2 reminds us the dinosaurs didn't have telescopes. We do. Whether we use them wisely decides our future. Level 3. If solar flares are the sun sneezing, gamma ray bursts are the universe firing a sniper rifle. Gamma ray bursts, GRBS, are the most powerful explosions known. They happen when massive stars collapse into black holes or when two neutron stars collide. For a few seconds, they outshine entire galaxies. The danger isn't the explosion itself, it's the focused beam of radiation they shoot, like a cosmic laser pointer. If Earth ever stood in its line of fire, the ozone layer could be burned away in seconds, leaving us exposed to lethal solar radiation. Here's the terrifying part. They travel at light speed. There is no warning. If one were aimed at us, the first sign we'd get is our atmosphere unraveling. Scientists think a GRB might have caused the Ordovician extinction 450 million years ago, which wiped out nearly 85% of species. It's still debated, but it shows what these cosmic rifles are capable of. It's like standing in a crowd and someone points a laser directly at your eyes. Out of billions of directions, it only takes one unlucky aim. Thankfully, most GRBs happen billions of light years away, far from Earth's crosshairs. But still, the thought of a random, instantaneous wipeout keeps astronomers awake at night. Level 3 is not common, but it's deadly precise. Level 4. Not all dangers are explosions or impacts. Some are quiet, slow. Meet the drifters of space, rogue planets and wandering stars. These are worlds and suns torn free from their systems, kicked out during cosmic chaos. They drift silently, with no orbit, no home, nothing to stop them. Some studies suggest rogue planets may be as numerous as stars, but estimates remain uncertain. Now imagine one crossing into our solar system. Even without a direct collision, its gravity could destabilize orbits, tugging Earth into a new path, altering seasons, or slingshotting planets into interstellar space. Worst case, it could crash directly, turning our planet into molten rubble. It's like discovering your quiet neighborhood has a tank rolling down the street, and it doesn't care where it parks. The scary part is detection. Rogue planets don't shine like stars. They're black silhouettes against blacker space. Unless one passes in front of background light, we might never see it coming. The chances of a direct hit are astronomically low, but in a galaxy this big, low probability is not zero. And even a near miss could spell chaos for the delicate orbits that keep Earth habitable. Level 4 is the silent wrecking ball of space, and if it comes knocking, we won't get much warning. Level 5. We've already seen what asteroids can do, but those are just space pebbles. Now imagine something far larger, planets themselves on a collision course. In the early days of our solar system, this wasn't imagination, it was reality. The Earth was struck by a Mars-sized body, Theia. The result? Our moon. A cosmic scar turned into a celestial companion. Today, planetary collisions within our solar system are unlikely. Orbits have stabilized over billions of years, but in the far, far future, gravitational shifts from passing stars or galactic mergers could destabilize planetary paths. Worlds that once circled safely could be nudged into chaos. Think of it as cosmic billiards. The balls are planets, the table is gravity, and sometimes the cue stick strikes without warning. For humans, a planetary collision is absolute. No bunker, no shield, no miracle could save life. It is an end written not in minutes or years, but in a single violent instant. Level 6. A star is not forever. Some burn gently into white dwarfs, others collapse violently, exploding with unimaginable force. A supernova, if one happened close enough, say within 30 light years, it could sterilize Earth. The blast of radiation would strip away our ozone, exposing life to deadly ultraviolet rays. Oceans would shimmer under an invisible executioner. Crops would fail. Species would vanish. The nearest star that could go supernova in the cosmic future? Betelgeuse, a red supergiant, already swelling, already unstable. If it does blow, it would be spectacular, but safe because it's around 642 light-years away. A dazzling show, not destruction. But not all neighbors are so kind. The galaxy is full of ticking stars, each carrying within them a death sentence waiting to unfold. Imagine standing under the night sky and knowing at any moment one of those distant lights could erase everything below it. Level 7. Now we climb into stranger territory, a threat most people have never heard of. Magnetars. Magnetars are neutron stars taken to extremes. Imagine a collapsed core, only 20 kilometers wide, yet packing more mass than our Sun. But that isn't the scariest part. What makes magnetars terrifying is their magnetic field, so powerful it could erase credit cards from hundreds of thousands of kilometers away. Every so often, magnetars erupt. A starquake cracks their crust, releasing a burst of gamma and X-rays thousands of times brighter than the Sun. In 2004, one such flare from SGR 1806-20, 50,000 light-years away, briefly disturbed Earth's ionosphere. And that was from halfway across the galaxy. Now imagine if one were much closer, say within a few thousand light-years. The radiation could strip ozone, fry satellites, and bathe Earth in an invisible storm no technology could withstand. DNA itself would be at risk. Magnetars remind us that danger doesn't always come from explosions or collisions. Sometimes it comes from a cosmic spark, so brief, so violent, that it makes the Sun look tame. Level 8. Black holes are gravity perfected, places where space folds in on itself, where time stretches, where light cannot escape. From a distance, they're harmless. Our own galaxy's central black hole, Sagittarius, A star, is stable, massive, and unimaginably far from threatening us. But what if a rogue black hole drifted closer? It wouldn't need to collide with Earth. Its gravity alone could distort orbits, drag planets astray, tear the solar system apart. Come closer still, and Earth would feel the spaghettification effect, the stretching of space-time itself. Oceans would lift, crusts would tear, humanity would vanish into a silence beyond silence. It sounds unlikely, and it is. Rogue black holes are rare, but the cosmos is vast, and we are a speck adrift. For all we know, one could be wandering the dark, unseen, until the moment its pull tightens. Level 9. Now we step away from immediate threats and into the realm of the ultimate. The timeline stretches not millions, not billions, but trillions of years. Stars burn out, galaxies fade, black holes evaporate. Entropy, the law of disorder, keeps marching forward. Energy spreads thinner, temperatures approach absolute zero. Eventually, nothing happens anymore. No stars to ignite, no warmth to stir atoms, just eternal stillness. This is the so-called heat death of the universe. Not fire, not explosion, just silence. A cosmos where time still ticks, but nothing stirs. It's not a sudden ending, it's a slow fade, like watching a fire die into embers, then ash, then darkness. Humans, by then, long gone. But the idea of existence itself ending, not with a bang, but with endless cold, has haunted cosmologists for generations. Level 10. Now, the strangest, most terrifying possibility, the one that doesn't just destroy Earth, but rewrites the laws of reality itself. Vacuum decay. Physics tells us our universe exists in what's called a false vacuum. Stable, yes, but not necessarily the most stable state possible. Think of it like sitting in a valley, safe, calm, unmoving. But just over the ridge is a deeper valley, lower and more stable. If a random quantum fluctuation triggered a collapse, the universe could tunnel into that deeper valley. A bubble of true vacuum would form, expanding at the speed of light. Everything it touches, erased. Atoms split, forces rewritten, chemistry, biology, matter as we know it, gone. There would be no warning, no survivors. One moment, Earth is here. The next, it's gone, erased by a law of physics more fundamental than any we understand. Is it likely? Probably not anytime soon, but unlikely in a universe this vast still leaves a shadow. Now, what could truly end everything? And the answer is layered. Some endings roar in fire, asteroids, supernovae, gamma-ray bursts. Some whisper in silence, heat death, entropy, the fading of all stars. Others, they rewrite the script entirely, vacuum decay, the possibility that the very rules of existence could change in an instant. We look at the night sky and see beauty, but woven into that beauty are threats both subtle and staggering. One day, the curtain may fall, but tonight, the stars are still shining.